motion. Maybe it's impossible.
Turn it off and then make the thing go.
What's that?
Like you can dim them, right?
I don't know. Sure. Okay, so this is the database. There's this is what it'll look like too. So typically databases that we worked in, I'll change the way the navigation pane looks, but this was downloaded right off of this bull tests. So kind of what you need to start with. This is just some information. So we have like the beginning of when the test started. This is an ID that I made. I'll talk about it later. And I've already analyzed this, but I went through and deleted it all, so we're going to be kind of starting from scratch. So here's just information that wouldn't be collected like in the GrowSafe database, right? But we're going to use it to help pull information out. And then these weights, I think, came out of the beef system, so we're going to kind of look at them and play with them a little bit. And then everything that needs to be calculated, I deleted. So we'll get started. So the first thing I do with like a database is I typically put some dimension tables in it to reduce the data that we're going to play with. So the first one that we'll do is we'll make like an animal list. In most workbooks, I always have like a formula tab. And we're going to take this. Get rid of some information we don't want. We'll leave that. I don't care about this side here. So it's way easier to use like VID than EID when you're trying to track an animal through a system. The challenge is a lot of times, so like this data set's got like 4 tests in it. If people are using a 3-digit code based on like the order in which they were born, chances are you're going to have like 3 100s, 3 85s. So about 90% sure the way I made this ID is I just sorted them based on VID and ran a number down. So they're 1 through like 490 or whatever. And this is what we'll use to track them when we go through SAS. I don't care about.
You said this data set has 4 what? Text or tests?
Tests.
What does that mean?
So like here, we'll just do it quick. So bull test is 70 days. So a lot of times they don't have enough time within so what they'll do is they'll like take their light ends, test them, and then empty the system out, bring new animals in, right? So we need to keep track of that. We'll kind of create cohorts or something. So a lot of times if you're looking at stuff that's not like 1 iron, and the VID they're using is like their ranch tag, there's just duplicates. So the best way to test for duplicates is do a count if. And just roll down. So this tag shows up, this 615, even though it's a different animal, is 3 times. So if we're going to use that for some identification mark on that animal, it's going to suck because we won't be able to separate it. So when we go into SAS, we're going to say, okay, I want you to run all these regressions based on this animal's number. It won't do the EID because it's too many digits. You have to go in there and you have to say, okay, this field can be 15 digits long, and then it's a real bitch to keep track of it. So you can just give them some identifier as long as you just let make that stay with them. VIDs work really great as long as there's not duplicates. And then sometimes the duplicates show up as like, you'll have half the animals that have a numerical value, and then half the animals that's like red 5, blue 5, right? Like in the VID column. Mm-hmm. So now you have text and new numbers in the same column. And that's a real problem. So most of the things that we use, when it sees a number, it's going to say, okay, that's a number column. And if it sees a text, it's going to go, oh, that shouldn't be there, and it's going to drop it. So as you're going through these, the format of the data is important. So like anything that has a number in it, it's only a number is typically recognized as a number. Dates are numbers, everything else is text. Everything in the GrowSafe database is text. They don't separate, they don't delineate between it, which can be a bitch, and I'll kind of show you as we go through like what the errors look like. But so anyway, that's a good check if you're combining data sets. We're going to use this. We're going to call this a dimension table. So there's two types of tables. That's not true. There's lots of tables. Two we're going to talk about is one that actually holds data, so like it gets added to. Another one's a dimension. So a lot of times the way that you save space in a database is you don't bring along categorical variables, right? So for like dry matter intake, we don't want, inside that data table, we don't want to have, what breed is it, or the breed or the owner, all that. We don't need to store all that. It's just going to be like one number. Well, then that number will go to another spot, and we'll say, okay, associated with this number is all this other shit. So we're going to make an animal dimension table, and we're going to make a date dimension table, and we're going to use it to reduce the total amount of data that we're playing with. So this is the animal dimension table, and what it's going to contain is the animal number, other pertinent information about it. Is it a bull? What pen did it house in? Things that are kind of like global things that we don't have to record transactionally. So this will be our animal dimension, and then I'm going to go in here and I'm going to make a date dimension. And the date dimension is really important as well. So to make my date dimension, I'm going to kind of cheat.
You don't put weights in your animal dimension?
No, because so that's a really great
Identification
example. Let's. This is a good example. This is a. So it's really easy. I'm gonna pull up just standard kind of deal. So this is how I store weights, typically, right? I've got an animal, I've got a date. So it's really easy for me to input the data, right? Each column is a date. It's really easy for me to do like a real rough calculation of average daily gain. This is more like a report. This isn't data. I can't analyze this using any type of tool because each column is a day, right? And worse than that, it's like a date. It's not relative. So for me to analyze this, like in SAS or do anything with it, it needs to be transactional. So this is really a report. This isn't data. So this is what the transactional version would look like. So I've got an animal number, a date, a relative day, and a weight value, right? So instead of having it lots of columns, now this actually means something. And my relative date is a number that any type of analysis tool understands, right? It will do dates, but you have to transform. It's way easier just to transform it on relative. So this is what like the transactional version would look like. This is how we want all of our data. So we're going to make a table to kind of do that. We can do it in Access. Let's do it in Access. But first, so I need my start and end dates. So I'm going to use my data set there. I'm going to come down here. I'm going to say start date. Well, this is just to get a starter. Okay, I'm with you. All right.
use your data sheet or use your data RFI sheet?
I'm using the data RFI. The data had more stuff in it than we needed. There was like, you know, this animal failed and stuff, so I just chunk them. So this is, I just use this pivot table to make my start finish date for each data set. And we can do it over here. So what we want to do is we want to create a schedule that has all the dates in it that we think are relevant. So So we'll just start with data set 1. Start dates. And it ends 3/19. So I'm just essentially, I can do this, you can do this in Access, but I think it'll be confusing.
What is your objective right now?
Creating our relative day schedule. So we're going to use this to, so in the database, right? In any given database, let's just use this one. So let's say this database has 1 million rows of data, right? And I probably only really want to look at 500,000 rows of data. Well, the best way to reduce all of that is to specify what I want instead of what I don't want. So when we try to pull out intake, we'll say, okay, I want all the records for this animal on these days. So what it does is it'll first say, okay, you know, there's 10,000 animals, but we only need these 500, and then we only need these days. So we don't have to mess with the whole database. And also this is how we're gonna assign our relative day, right? So we've got 5 different trials that are all on different time schedules. So I can say, okay, relative day for data set 1 is 1:30. You know, day 0 for data set 1 is 1:30. Day 0 for data set 2 is actually 4:05. So we're going to put all the animals on the same measurement unit essentially, and then we'll analyze them all at once. So if you do it this way and you put some rules into it, when we start analyzing it, it doesn't matter if it's 10 rows or 10 million rows, it's going to take us the same amount of time. But if we go through and we're like, okay, we're going to just pull this one study out and do it, it's a bitch. So if I'm going to have to do it more than once, let's just code it, right? Because it just takes so much longer. And then if there's a problem, you can fix it faster because you're all in the same deal. Okay, so the best way to do our date change is just do a formula. See if I put them in the right order. Oh yes. So data set 2 starts on 405. We should be able to drag this down to 524. But it's 48 days.
How did you know how far to go to? Sorry.
I got my dates over there. I want to go to 524. And this is not what I wanted it to do. I thought about doing this beforehand, but I thought it'd be better to show everybody.
Would it ever be bad if you had like 2 trials running at the same time?
No, because I'm gonna go ahead and say that's. So
Great.
I do this. If you're gonna analyze a lot, so what we'll go through when we test RFI, we're gonna look see if there's a pen effect, right? So if there is a pen effect, we'll control for it and we'll just analyze them separately. So like when I did my masters, I don't know, it was like 2,000 bulls, and maybe that represented like 3 years of data, but I had like 35 cohorts in it. So I'll just use like the classifier as data set or cohort or whatever to differentiate between them. So if I've got like 2 heifer trials running at the same time, but I want to analyze them separately, I just give them a different class.
2 and 3 or
Whatever, yep, just give them a code. I mean, that's information that you should know, right? Or that you know, you don't need the system to tell you. Well, this is the short one. This is that like little heifer trial. These timelines are really short. So those are 2 studies that ran simultaneously or overlap, but it's our data qualifier. Save this. All right, so let's get to our access. So the first thing I do when I work in a database, this is like just the generic, object navigation pane. So you go to options, I'll switch it to custom, and I'll create some groups. So the first one I typically always call is GS tables. And what that is just all the actual tables in the GrowSafe system. I make one for dimension tables. Make one for feed intake. We'll call it bunk visit events. Time to bunk. And we'll do weight events for this one because it's got a beef system.
What's the beef system?
It's an in-pen weighing system.
Like the water?
Yeah. So then it'll change my So we'll grab all my GrowSafe tables. So the cool thing, the reason I do this is there's a lot of tables in here I never use, and to save space, I can just say I don't want to see them. You know what I mean? So like you're creating folders in there, so when you're trying to go back and forth, because what we'll do is we'll create like clusters around stuff. So we'll have like an analysis for intake, and we'll have something for this and that, and then once we create that information, we can make like bigger tables where we'll say, okay, pull this from this based on this day, and you can start actually making it work just for data organization. Okay, so we're going to create a table. The first table we're going to create is our dimension table, and the easiest way is you just do a Control-C and Control-V. So one of the big things working in Access is like keeping track of your rows. So when you're doing queries, typically you're like reducing data. So you want to kind of think about how many rows you have all the time. So normally I have like a notepad. So that we have 542 rows. So a good check is to just come back to Excel, and we got 542 rows, so it all transferred over. So now we'll make our date dimension. doesn't like the word date, but it can get over it. Did we not do that? I called date twice. It's telling me that because I have the word date, but I don't care. Okay. So we'll kind of start actually looking at the data now. So we'll start with feed intake, which I think is the easiest one. So the feed intake is in a table called intakes. So intakes has the pen number, how much they ate, the time labels, the date, and the EID. The EID, the time label, are stored as text. So we'll have to convert them to numbers, which is really easy. And we'll do that first, and then we'll use those to do our matches. So the first thing I'm going to do to create like a feed intakes table I can work with is I'm going to make a query. So to do that, I'll start over again. I go to create, query design. I never use the wizard. This will ask me the table, I just delete it and drag it over. So query is where we're going to do our formulas, where we're going to make our joins. This is how we're going to use like our data manipulation. So I'll take all of the columns over and put them in here. And if I run it, it's going to look just like the table. It should, right? It should have the same records. So like we've got 51,510 records in this data table query. So the first thing I want to do is convert this EID to a number. So I'll call it EID underscore number. It's really good to use underscores instead of spaces because we're going to use the names of these columns for formulas. And if you put a space, it's really hard to tell if it's one space or two spaces. So like if you double space for some reason, or if I do like EID space like that, that means EID space. It's an ANSI character. So if you don't bring that space with, it'll drive you insane. So I'm going to name, so the first thing I'm going to do is name the column EID number. And then I put the colon. And I can do that to change the column heading of any column in a query. So if I want to change pen to whatever, I can just do new name, colon, pen, like watch this. If we run it, it'll bring that same information over, it just changes the column heading. So if you want to change the column heading, that's the best way of doing it. All right, so EID number is going to be a formula. And we're not actually going to have to like do an open bracket because it's a real simple formula. So if I want to do any type of math, I can do it without saying that it's a formula. But I have to tell it which column to pull from. So I want to pull from EID. So the way I tell that is it's a bracket. I type the column heading in, and the easiest way to convert something from text to a number is to multiply it by 1. So I'm just going to multiply it by 1, and when I run it, it should give it to me like in this scientific notation. So now that I know that it's a number. The time label is a little bit different. We're going to kind of deconstruct it and reconstruct it. So I'm going to go month, day, year. Here I am going to have to use a formula, so the title of my formula is month. I'll do an open parenthesis just like in Excel. Same deal, brackets. Let's not label like that. And when I run it, it should just give me, okay, so like, it's telling me what the parameter value is, because it can't find it. So see how time labels time underscore label, and I did it like that. That's why I can't find it. It's asking me what's the what the parameter is. So if I fix it, it should go away. So now it's just giving me a number. So we'll do this. I'll actually kind of copy this. Actually, copy that. So now we have month, day, year. And then we're going to come back and we're going to put that into create it, make it a date. So I'll do this like, so one of the shitty things about GrowSafe's database construction is they name these things the same. So like this is time label. This is the feeding events table. That's also time label. That's a time and date stamp. That's a problem, right? They should be separate. So you kind of have to have some institutional knowledge of how the databases work. So we'll do the same thing for this. We'll go day, month, year, hour, minute, second, and then we can create a timestamp and we can create a date. So now we're gonna make our date, and it's we're gonna do a concatenated field. Anyway, let's see. So the all concatenated fields are stored as text. Essentially all we're doing is we're just mushing them together. So we're gonna have to do a C date, which is a convert date, open parentheses, and then it's gonna be month, close bracket, and then a comma for the next thing I wanna do, and we're gonna put a slash in it. So it's quotation marks because the slash is text. You know what? Let's do this.
Mr. H there.
I'm gonna zoom so we can all see it. Close quotation marks, parentheses, day. And now when we run it, hopefully it works. Oh, I'm sorry, I did this properly. Instead of these commas, it needs to be an and symbol. The commas are for Excel. There we go. So now we have an actual date. So all we've done is we started out with 4 columns, and now we have more. If we wanted to, intake stored in grams, we could make this kilograms real easy. Let's just do that right now. Okay, so now we want to save this. To save it, you just close it. We'll say yes. So we'll layer these queries. So what we'll do is it's almost like if you had like an Excel spreadsheet or a pivot table and saved it, and then analyzed off of that and saved it. but we can update them and they'll keep running. But naming them is important. So like I know this is going to be the first one in the sequence, so I'll call it feed intake 1. Also that way when they go on my navigation pane, they'll be in that order. So a lot of times if you end up with a problem in your query, you can kind of backtrack through it and find what's going on. So it'll fall to the bottom in this unassigned objects. We can put our dimensions in here. We'll put feed intake and feed intake. So one of the things we can do now is we'll keep going. So the next thing we need to do is bring in our good or bad days. So I'll create a query design again. I'll take my feed intake 1. And here I'll probably just start using our new ones. Date, EID, dry matter intake. And the table that has the good and bad day information is called pen check. And this is what it looks like. It gives you the first node, the last node, the status for each day. So OK is good, F is bad, S is a skip. And we'll use this. So the way Gordon likes to do it is to go through and check the AFDs. And we'll do that as well, which is the assigned feed disappearance. So when we look at the bunk visit stuff, we'll kind of build that and we'll compare them. I always use the pen check. I think it's better. But when we do the individuals, we'll have to pull the AFDs in, and then we'll look at the averages. So this is the pen check. So it's got the time label, the pen, all that kind of stuff. So what we're going to do is we're going to take information from our previous query, and we are going to bring in the pen check information. So we're going to join these together. If I have a mismatched join, I'll get a shitload of records. So if for some reason, if I just ran this, I think there's like 51,000 rows in here. What it'll do is it'll give us every possible combination of the pen check table and the feed intake table. So it'll be like 50,000 times 50,000, right? So that's a good way of knowing like, okay, my query is not working, there's something wrong. So we're gonna match our time label, which is our text date, because we're not gonna convert this pen check table to that. And we're gonna match our pen to our pen, and then we're gonna bring our status in. And these are complete joins. So there's 3 types of joins you can do. You can do inner, outer, and complete. And the inner and the outer are the same, it's just the direction in which you're going. So a complete join only brings records where they match 100%. So this is how we can reduce our data. Inners and outers will bring information if it matches, but won't reduce from which table you're starting from. So like, if this table had 1 million records, which were important to me, and this table had 500,000 records, I still want to see this million, but I want the 500,000 where it matches, I can do an outer, and you'll just see a bunch of blanks where they don't match. And this is a really great way if you have like, if you're trying to compare 2 data sets, or like your time stuff, right? Where we have like, we know these are all the days we want, and here's some information associated with it, you can pull that in with an outer.
So if you did complete, it would just take the tables that matched on both of them. So it would
Exactly.
be-
Yeah, so so it'll reduce it. So when we run this, now we should see our status. We're gonna leave that in there. So I'm gonna close this. I think I called it feed intake.
So why did you drop all the other variables that you had in feed intake 1?
Because I didn't need them.
Okay.
I can always bring them back if I need to, but I don't really need them.
Okay.
So now we're gonna reduce this. So we got 50,503 records, which is less than we started, right? We had like 51,000. Well, if an animal's in the system, it'll record it, but if it's not on trial, it won't bring it in. So like if you start a study, but you don't tell GrowSafe, and the data's still recording good, but they're not checking it, it won't have a pen intake deal. So that's when, if you're like, oh man, I'm missing the first week just because they didn't flip a switch in it, you can do the AFD thing and go back and keep that data.
So
But we
that's
get.
what he does it because he feels like it's more complete.
Hmm?
He feels like it's more complete if there's any like messes up or Dr. Karsten's.
Yeah, he just prefers it. So now we're gonna reduce it. So we got 50,500 records. So we're gonna create our query design again, and we're gonna pull feed intakes 2, and we'll pull our animal dimension in. So I like to lead off with the date. So here we're just gonna say all we have to match to is our animal number, but I'll probably put proceed data set. So our EID number should match our EID. So we have data set, date, WKID, pull reg number in, their VID. I don't need any of that shit. Dry matter intake and status. So when we run this puppy, we went from 50,000 rows to 35,000 rows, right? So since we made that dimension table, there's 15,000 records we don't need to mess with anymore. We're gonna call this feed intake. Three, and now we're gonna put our date qualifier on it. And you can really do that in which order you choose, you know what I mean, the date or the animal. So feed intake 3 comes in. We want all of this information still. Our date dimension is going to give us our relative day. So here we have 2 joins to make, data set and date. And then we're going to pull day in front of date. We're going to run it. So now we have our relative day, data set, animal. Now we're at 26,000 rows. So there was a lot of records in there of these animals, but they weren't really on test yet, right? Probably 2 weeks of warm up, and we don't care about that for what we're doing. So now we have something we can actually analyze. So we'll take this and we'll put it, we'll make like a weights book. I'm actually going to do it in, not a weights book. I'll put it in the sheet, and I'll call it intakes. So there's 2 things, right? This has all the days. Now in here, is there a fail day in here? There better be. So we got some fail days, right? So we're gonna have to go through and we'll create like a linear regression model to compute that value. But I need that day as a placeholder. So right now we're going to copy this whole thing over.
You join data set and what on that last query?
Data set and date. And then I'm going to go in here, I'm going to close this, and I'll call this feed intake final. All right, now I want to get rid of, I want this as a placeholder for that day, but I don't want that value going into my regression equation. You know what I'm saying? I want that to be not present for the regression analysis. So I can do that really easy and create like a data set to run through SAS. I just bring my query back into here. I go to my status and my criteria, this is essentially just like a filter. I make it okay. So we can do this for a lot of things. If you're just trying to, if we said, oh, we only want data set 1, we can put 1. If we said we want all the data sets except 1, we could do it doesn't equal 1. Or you could do 1, 3, and 5. You can put whatever in these. So when I hit OK, we were at like 26,000 rows. Now we're at 25,000. So we took all the ones that we didn't want. I'll call this one. I'll call this one intake size as well. Alright, so now we're ready to do, let's do our weights too. I'm just gonna check something here. Excuse me.
You pulled all the headings, right?
Yeah, I'm just checking something real quick.
Is this from the beef thing?
No, these are shoot weights.
So they.
I might pull the shoot weights along if we can. Just real quickly. They just took initial weights. So if I want to sort this, I don't see any duplicates.
So like for this one, I mean I guess I don't really know what you're doing, but if you check the columns, you went from like 450 to 350 or 360.
Yeah, it's just all the animals. That's a different query.
Oh.
I was just checking something real quick. Okay, so let's do our linear regression for intake. I'm just gonna pull a piece of code over. Okay, so first thing we need to do is show the model where it's at. So I'm going to copy the address, and it should be combined underscore example. Call it intake SAS, which is the same here. So when I run this, it's not going to work. Check it out. It doesn't like it because I have this open. So as soon as I close it and run it,
You called it intake, not intakes.
so it's telling us how many observations, how many variables. That looks all appropriate. So if I printed it, I can get my column headings, but I'm pretty sure I remember them. So we got to sort it first. It should be WK ID day. See if that works. Yeah. So then this is our model. It's pretty simple. So it's a GLM. We'll do the dry matter intake kilograms. I don't want the solution, but I do want
What is that?
I'm telling it no intercept. I don't want to adjust for the intercept. We're essentially just doing the regression. So we're saying we want to know what dry matter intake is for each animal based upon the day by animal interaction. It's running. So it should look like a bunch of gobbledygook like that. Shit. Third time's the charm. Maybe I didn't do the solution.
So you're regressing like every animal, but you're doing like you're combining all the data sets. So would that mess up your? It doesn't matter.
By making my WKID a class variable, it separates them for each. So if we didn't have a class variable in there and we just did like day by WKID, then yes, it would not work. That's what we're looking for. So this is essentially the day 0 and the slope for all animals. So we're going to copy it.
Oh, because it regressed every animal individually.
Mm-hmm. Okay, so we're in the intake SAS tab already. This is where I drop my formula, my model. Okay, so this is worth a conversation anyway. So this is the ID, and what we have first is the day 0 value, and then way down here is going to be the slope. So this is the p-value for the slope, right? So Lydia, since you have both 651 and 652 under your belt,
I think Lauren probably does too.
what's the p-value? Tell me about that number.
But it is not significant.
That's a good guess, you think
It's not significant. Why isn't it significant? What's that testing?
Oh, different than 0?
So it's saying, essentially saying that there's no real slope. So if there's no slope, it means that you're,
It's an unchanged intake.
no, there's no effective day. So essentially your average is your slope. Not your slope, but you know what I'm saying? There's no slope, so there's no reason to do a linear regression
For that.
input. Right, we're still gonna do it, but it would be just as easy just to take the average and replace those days if we were worried about it. So we need to kind of parse this thing out. So we want the 1 through 400. We don't want the WKID preceding it. So to just get the 1 out, just to extract the 1, we'll do a right formula.
What is the top chunk of that table?
The intercept, but there's no intercept, so it's really just the day 0 value.
Oh, okay.
Yeah.
So that's how much they ate on day 0?
Yeah,
Theoretically.
essentially. So I'm gonna do a right because I just want the number that's on the right. So I'm gonna say I want that value, and then for my number of characters, since it's gonna change from 1 digit to 3 digits, I do a length. So which counts the amount of numbers in a cell, the string in a cell, and I'm gonna subtract it by the WKID space. So I'm gonna subtract it by 6. Then I'm going to multiply by 1 to make it a number again. Oh, there's the tool. So as it rolls down, it should pull the number out. I'm going to paste those values over. Okay, so I'm going to change our estimate to, I'll call it day 0. Then I don't care about any of this shit. I'm gonna call this the DACO. And if we were doing this for body weights, that would be average daily gain, right? Go down here till it gets crazy. We've got the same number of rows. This can all go away. Okay, so now we got our model. So we're going to go back into our intake, and we're going to put it in there. So I'm gonna calculate intake for every day, and you can name it whatever you want, but I do DMI regress or whatever makes sense to you. So we're gonna do an index and match formula and pull it back in. So we start with equals index, and we're gonna go select the array we want to pull from. D, column D has our animal IDs, so that's what we're gonna use to pull the information back in. So I'm gonna select this array, hit F4 so it doesn't move. Find it here. So that's going to bring in my day 0, but I need the full regression equation, right? So I can just copy this over. And do plus my DACO. Multiplied by my day on feet. So that's one of the reasons to put it on relative day. When we can analyze it too, it makes this really easy. So as we drag this down, these should change. Some sorted by animal. Here, we'll do this real quick. So see how it's just slightly changing, right? I mean, it's 0.03 of a kilogram a day. So now we need to go and we're gonna call it, what the hell do we normally call it? Let's call this predicted DMI. Call this, so what we're essentially saying is, okay, if the status is good, so this is one of the things I don't like about the regression, right? See how much higher that is initially, right? You know what I mean? But, I mean, it's gonna fluctuate. But. So our corrected dry matter intake is, I'll do an if statement. This equals okay. Then put the actual dry matter intake. If not, put the predicted dry matter intake. So every day there's a fail, it pulls in the predicted, otherwise it leaves what we actually measure. And then we can do our daily intake variation, which is essentially the daily residual of the predicted versus the actual. All right, so now we got our intake. We're gonna wanna pull it back into this RFI workbook. And stick it right there. These are all in pounds.
Wait, real quick, can I ask a question?
Mhm.
Did you go predicted dry matter intake minus actual?
Actual minus expected.
Does it matter?
Yes. For that, not really, because we're gonna run a standard deviation on it. But if you're talking about the true residual, yeah, I mean, it would matter. Because otherwise it would be backwards, right? Like if you talked about RFI and you did it the wrong way,
Mm-hmm.
positive RFI animals would have eaten less intake, do you know what I mean? So
Okay.
yes and no. All right. The easiest way to pull this back in is to go into here and make a pivot table. The ID, dry matter intake. I'm sorry, it's not the one we wanted. Our corrected dry matter intake and our daily variation. I'm gonna switch this to an average. I'm gonna switch this to a standard deviation. So now we've got it summarized. And then to bring that in, I'll come in here and I'll do equals. Let me name this first. Go to my pivot table and just select a number. And that's just looking at that record. So what it's saying is, do a get pivot, go to average of corrected dry matter intake. The the ID equals this one. And I'm gonna delete the one and put the cell number that has that ID in it. And it'll link it up. Same thing for the variation. Okay, this is in it's in kilograms. There's a lot of feet.
So 40 pounds.
It's a lot. So we will. Another thing too is that in GrowSafe, it's not your dry matter intake, right? It's the as-fed intake. So let me do something really quick. We'll just let it roll for now. Shit. Because we don't know what their dry matter percent is, but we can put it back into pounds. We can calculate our feed to gain.
Send you the link to the video, Chris.
What's that?
I'll send you the link.
Alright, thanks.
See, man,
Sorry, I gotta leave a little bit.
you're good. So like that feed to gain looks pretty shitty because the dry matter intake is so high. I really think that it's like 0.5 is their ration. Kind of looks more about right. So then once we have our dry matter intake calculated, we can calculate the RFI. So to calculate RFI, we need metabolic midweight. That's stupid. So metabolic midweight is the difference, is the average weight to the 3/4 power, right? You guys have Gordon gone into allometry yet?
Yeah, in a way that I don't understand.
So that's what we're doing here, is we're putting them on an allometric basis with each other. So that's just the end weight. Actually, we can do it like this.
Average of the day.
S2 or R2.
Oh yeah, I used to click start date. How'd you convert it to just the 2 decimals?
Shift control 1. Do you guys want to go through the RFI calculation right now?
Sure.
Okay.
We have through until 1.
Okay.
Is that a thing you can do in 20 minutes?
Oh yeah. Fast like lightning. Actually got an RFI model already. So WKID, dry matter intake, actually. So this is the model. So here we're running it by data set, right? Do you know what I mean? So we don't want to run all the animals together. We don't want to run bulls and heifers or different stuff. We want to separate. If you had breed, you would do it by data set and breed or something like that. The ID that says WKID, what that's doing is it's just bringing that ID back in the analysis, into the report. Do you know what I mean? Otherwise, it would just give you like record 1, record 2, record 3, record 4. By specifying the ID, it'll actually take the number that we gave it. The model is simple. It's just dry matter intake equals average daily gain and body weight to the 3/4 power. And it's gonna actually calculate the RFI for us.
Wait, it knows what RFI is?
No, it knows what R is, and R is RFI.
Yeah, so the R is the residual, and I said, this is a data set right here. I said residual equals RFI, and then bring out RFI, yeah. So it's for each data set now. And we can just copy and paste it over. You can solve for it, and you can put the, I mean, you can calculate it if you want.
In SAS?
No, in Excel, you could just take this and you can calculate it. It's definitely easier just to copy and paste it. We could probably use, we could use like data set as a class variable, you know what I mean? And calculate it that way, but I'm always worried that it's not gonna, I'd rather run it separately than hold it as an effect in the model.
heart rate reading right now? Mine's not reading.
So it's the level on your chest.
Huh?
Lick your hand and stick it on your chest underneath the reader. Yeah, I'm at 95, sitting here.
95? Does that have to do with your heart thing? It's like.
Give me hot palpitations.
Yeah.
No uppers for this one.
No uppers?
Only on Tuesdays.
Oh, I was like.
Okay, so we don't need any of this shit. We've got a predicted versus, so the predicted is essentially how much we thought it should have eaten, right? And the residual. So this guy ate more than based on the population. So we can come back in here.
So it creates a big population regression instead of for that animal?
So no, so
Like
you,
as far as what you did for the intake before?
so we did the intake on each individual animal. We just wanted to model it for him. Right, so for each animal, you have day. Right, and you got whatever. And we drew a line because if there's a missing day here, we want to kind of get a best estimate of it.
That's what we did a minute ago.
Yeah, now for RFI, you have, it's not true. It's kind of hard to draw, right? So this would have to be like dry matter intake, and this would be it's multiple, right? But
Yeah, metabolic body weight.
yeah, so it's really like it's a cube. It's not necessarily a two-dimensional plane, but so for a level of dry matter intake, animals that are bigger eat more, right?
Mhm.
So for that, we drew a line through that, and we said, okay, these guys are efficient. These guys aren't efficient. Check it out. It's giving me the wrong plot, but we'll plot it in Excel and I'll show you.
So it compares them based on their weight, so you're not like discounting a big guy just because he's big.
Exactly.
Okay.
Yep. But it's based on his allometric weight.
Which I really don't understand because all that. I guess it. No, I guess I do understand. So it would be like that.
Bigger animals are more efficient because they don't lose as much heat for radiation, right? So it's not giving them the benefit of eating less for their size.
But it's still the RFI is based on the whole group. It's not just him.
Yep, the whole group. Yep. So I'll pull this in and we'll look at it.
Whenever, so real quick, I know you're doing that, but like in your SAS model, how did it know to look at? Oh, I guess I understand. Because whenever you specified ID, it brought back.
I'm sorry.
Yeah, never mind. It was a bad question.
No, I looked at a text. Index. I don't know what it is. I think it's B2.
Do you ever use VLOOKUP?
I think they're the same. No, I don't. And really, the only reason I don't is because I'm comfortable with this.
I need to like zoom in on that formula because you always do that so fast.
You know how to do this yet?
Let me put it up here.
No, I can see the whole screen back here.
Oh, okay. This thing sucks.
Yeah, I loosened mine up a little bit.
Does it have to be like right in the middle of my body? It's like
Mhm.
there's like, huh?
Well, the electrode needs to be in the middle.
So check this out, right? It's not working. Wah, wah, wah. It's either because I spelled something wrong. It's not, I mean, that's the tab number.
Match B2 with the column header.
I don't know, let's just rewrite it.
One time I get a picture of it, you fucking wrote it wrong.
We had those switched on.
I don't think so. Here's another thing too. Typically report RFI in kilograms. Right, we run the thing in kilograms. Doesn't matter if we're running pounds or kilograms. See what I'm saying? It's a regression equation. But this is in pounds, right? So it's just high. You know what I'm saying? So someone would be like, oh shit, 3.51, that's a lot, because you think in kilograms, it's in pounds. So the best way to check that your model works is to look at the distribution of it. So we're gonna separate the population by half a standard deviation. So we're gonna do that by this. So we're gonna have data set. We're gonna have this twice. What should the average of my residuals be?
1, 0, 2, 3.
That was weird. So we're good there.
What do you mean we're good? That's not 0.
Negative 2.29 to the negative 10 is probably pretty close to 0.
Oh, okay.
Sometimes they will be positive or negative, like 0.3, 0.4. And I think that's okay. Really, it's just telling that you probably got, there's two things. If your residuals, if the average of your residual is like, 0.5, it might be because you've got real different animals in that pen. So like, if we had residuals that were, let's say we had our residuals were 0.5, it could be because we've got like 75 Hereford bulls in there and like 25 Angus bulls, and they're pushing that curve. Do you know what I mean? So sometimes when that happens, you gotta, if there's a reason for it, right, where this is not a normally distributed population, go back and recalculate your RFI model and control for it. If it isn't, just live with it. So we're going to use half of this value to segregate our animals. So this is another if statement.
Wait, sorry, go back to your pivot table. What were we looking at?
Standard.
The standard deviation and the average.
Okay.
So to come up with a class, the formula is going to look complicated, but it's not. But it's an if statement. So I do if that is greater than that multiplied by 0.5, then put high, comma, if AG2 is less than that, So we have to come back in here. So we're like, this is our data set deal, right? And it's a get pivot, so that should probably be A2. And you should be A2. Nope. C2. The best way to check it when you're looking at that is like, you know, if it's high, does it make sense? But now we want to make sure that our distribution's right. So, so I'm going to do a pivot table. Well, actually, no, I'll just come back in here. I'm going to copy this pivot table. I'm going to refresh it. And what I'm going to do is I'm going to say, all right, I want to know what my RFI class is. Don't want any of this shit. I'm going to put my low over here because it makes more sense to me. And then we're going to do a count of something we all know they have, like an ID. And we're going to show that as a percentage of the row total. And I want about 30, right? 33.3 would be perfect. This data set's a little heavy on the average, and that's actually pretty common. You know what I mean? We're not perfectly normally distributed. I wouldn't expect us to be. So that's pretty good. So now we've got them class, we've got them put in RFI, we've got them class. This is a great way to class anything that's normally distributed, really. So for like exit velocity, average daily gain, whatever, if you're trying to look at population. So
By the standard deviation, you mean?
it's normally distributed. So RFI itself doesn't tell you shit. If I'm trying to look at a bull that was measured in Missouri, and I want to compare them to a bull that was measured in Montana, it doesn't mean anything. The actual value. Do you know what I'm saying?
Okay. You mean like relative to the...
Let's see, one bull in Missouri's got, or let's look at it this way, you've got a real high-powered efficient Angus type animal that's got a 0 RFI, and you've got a Hereford bull that's got a 0 RFI. This bull's going to eat more because he was tested with his peers. Do you know what I'm saying? So it's really just based on the population that they were tested in. Did they do better or worse? But if I want to buy an efficient bull, and I like the group of bulls he came out of, if I buy a low, it's probably similar to a low somewhere else. Do you know what I mean? The actual number itself doesn't really mean that much. And if if I'm a breeder, right, and I'm trying to make progress in RFI, it's impossible. Do you know what I'm saying?
The value.
My average RFI should always be 0. So if I got a bull sale with all the negative, and all the bulls are negative in RFI, where are the rest of them? Do you know what I mean?
Right.
So
But if you continually to like test them against every other breeder's bulls,
You
then
can't.
maybe yours would go in.
So you need to report your RFI and like feed to gain or something every
Yeah.
time. So
Gain.
there's
Yep, RFI and gains.
something to show.
So RFI is a great way of saying, okay, here's 50 animals, which is the best one in those 50 animals. So this is a sneaky way these guys do it. So if I want to have a negative RFI, right, for my herd, the easiest way to do it is to test all of them. The ones that were greater than 0, I retest. Half of them are going to be negative. Do you know what I'm saying?
You just continually retest.
Well, that's no. I mean, that's you'll see that where they tested above 0, so then they retest them again. Well, half have to be above 0 and half have to be below 0. Regardless, you know what I mean? So anyway, that's how it works. We can go through the feed intake stuff too. Some of the feeding behavior stuff. It's a little bit more intense just because it gets down to more minutia of the data, but
that done